All right, everyone. I think I'm going to do the last 8, 9, 10, 12 all in one video. I apologize if you have to search for some of these, but they're all kind of short. So number 8 says, if everything else in your sample is left unchanged, what happens to the length of the confidence interval as the sample size increases? So just remember that this is my formula, right? So if we just remember the formula, if the sample size increases, the interval decreases. It gets smaller. You can just try it if you want, but you can see that algebra, the number in the denominator gets bigger, that margin of error gets smaller, my interval decreases. And then part B says what happens to the length of the confidence interval as the degree of level of confidence increases. So remember that. So that's like going from 95% to like 99%. So that means Z is going to get bigger, right? Because we're going to move out that way. So Z gets bigger means my interval gets bigger. The more confident you are, the bigger the interval has to be. That's the way I always think about it. Okay. If I have an interval that's going from like 40% to 42%, that's really small. I'm probably not going to be as confident, but if it's going from 40 to 50, I can be more confident. I can be 100% confident. It's somewhere between 0 and 100, which is a little bit silly, but that's kind of the way I think about it to remember which one's which. That was 8. Number 9, explain the difference between P and P hat, which is the parameter, which one's always in the confidence interval. So we didn't use this word yet. P is called a parameter. It goes with the population. Population. P hat is a sample. Okay, goes with a sample, right? It's also called a statistic sometimes. So which one's always in the confidence interval? P hat, always in the confidence interval. P hat, always in interval. P, we don't know. So sometimes it is, sometimes it's not. We're hoping it is, right? But P hat is always in the confidence interval. Number 10, you want a margin of error that's 1/4 what you estimate it will be with your current sample size. By what factors should you increase the sample size? Remember, my margin of error is coming from this, right? So if I get 1/4, I want that, everything else is going to stay the same. Those are not changing. Those are not changing. So we could just call those ones if we wanted to, right? But if I want 1/4, okay, I think if I wanted to say 1/4, yeah, but what if we want the margin of error to be 1/4? So that means what number do I have to put in for n to make it 1/4? Right, so we're going to have to make it bigger, right? So I think we want to make it 16 times bigger, right? 16 times bigger. We'll make that square root of 16n become a 1/4. So 16 times bigger. Okay. And you can just try some numbers too if you want to see that. So, and then the last one, it's number 12. The survey was conducted to determine what adults prefer in cell phone services. The results of the survey showed 73% wanted email service with a margin of error plus or minus 4%. What does that plus or minus 4% mean? I was going to tell you the answer. You can read them. Some of them are a little bit nonsensical. Remember, the margin of error is where we think it's going to be, right? So if you read D, it says it would be unlikely to get the observed sample proportion of 73% unless the actual percentage of adults who want email service is between 69 and 77. That's kind of what that 4% means. There's no probability attached to it. There's no what percent of the survey was attached to it. There's no probability for B. So the answer to that one is D. So hopefully that helped a little bit. If not, we're going to go over more of them in class on Friday.